Hey everyone, I hope all of you guys are doing good and staying safe. In the previous video, we learned a lot about how we mapped our networking 101 to the default VPC that was created in each and every region for us, which already had each and every subnet mapped to its respective availability zones that were available in that region. And then we saw a little bit about the internet gateway, how it's mapped to a VPC. We took a look at the route table, which is the main route table that is created for the default VPC. And we also took a look at the routes. So in this video, what we are going to do is we are going to take a look at how you create a highly available network architecture where you have a public subnet and a private subnet. And this is something that we are going to create through the launch wizard of VPC. And that's the easiest way of creating a network with a predefined set of templates. So I'm just going to walk you through this network diagram over here. So in this network diagram, we have the AWS cloud within which we have a VPC in a region, out of which that VPC's range is 10.0.0.0/16. And that's our network range, which means we have 65,536 total number of IP addresses, which is 2 power 16. And then what we are doing is we are subnetting this big network into two smaller subnets. So we are subnetting into a public subnet and a private subnet. So the public subnet over here has the IP range of 10.0.0.0/24, which means it has a total of 256 IP addresses, which is 2 power 8. But then on the AWS side, we know that for every subnetwork, 5 IPs are going to be reserved. So we have a total number of 251 available IP address for our host that sits within the public subnet. And then we have this private subnet where we have 10.0.1.0/24. And now we are going to look at the route tables. So we have a custom route table that is associated with the public subnet. And we have a main route table, which is created when the network itself is created, which is attached to the private subnet. So now this main route table, which is associated with the private subnet, has a route pointing to the NAT gateway. So this main route table will have a local route, as well as it will have a route which states 0.0.0.0/0 should go to the NAT gateway. Whereas in this custom route table, which is associated with the public subnet, you will have a 0.0.0.0 route going to the internet gateway. And this NAT gateway will be a NAT gateway which is public in nature. And this NAT gateway will always be residing in the public subnet. And this NAT gateway will have an elastic IP or a static IP that is allocated to it, which lives throughout the life cycle of your NAT gateway. So just to revisit the traffic, any resource that you place within your private subnet, that traffic is going to go through the NAT gateway. The NAT gateway has the intelligence to network address, translate that IP address to its own elastic IP and maintain a NAT table, and then send out the traffic through the internet gateway to the internet. And then when the reverse traffic comes back, it again comes back to the NAT gateway, where the NAT gateway unnats the traffic based on its NAT table entry and sends back the traffic to the private subnet resource. Now, if you place a resource into the public subnet, automatically that resource has traffic to the internet gateway through 0.0.0.0/0 to go through the internet gateway. So all the resources that you place into the public subnet by default has internet access, whereas the resources that you place into the private subnet has internet access through a concept called as NAT gateway. And the NAT gateway is something that is fully managed and highly available and is managed by AWS. All we have to do is create the NAT gateway and give it a name and place it into the public subnet and modify our route tables for our private subnet accordingly to point the traffic to the NAT gateway. And then one more thing that you need to note over here is we have two network security controls, out of which I have depicted one is a network access control list. So by default, when you use the VPC launch wizard, you will have one network access control list for your network, which is associated with both the subnets. But I'll show you one more architecture diagram on an organization level where we have a tiered subnet strategy, where we will have network access control list per subnet tier. See, the network access control list is something that is sitting on a subnet layer, and it protects all of your traffic that goes into your subnet, and it protects all of the traffic that could go outside of your subnet. So inbound and outbound is taken care of by a network access control list. And later, I will explain in more detail about a NACL. So I hope you guys understood this particular network diagram where we have mapped the public subnet to an availability zone and a private subnet to another availability zone. And in that way, we are going to start creating this network architecture through something called as the VPC wizard. And then we are going to map it back to this diagram and see if all the resources that we created through the VPC wizard is matching this particular diagram. So I'll see you all in the next lecture where we work with the VPC wizard and what it has. So let's take a look at it. I'll see you guys in the next video. Have a great day. Have fun. See you all. Take care. Bye-bye.